Hello, my name is Dravid, and in this video, I will be teaching you how to disassemble and reassemble a custom PC. First, you want to unmount the power supply, but to do that first, you must unplug all of the wiring for every single component. First, I unplugged the wiring for the motherboard, for fans, the hard drive, and the CPU power. Next, I unmount the screws while wearing static protection to make sure I do not damage any internal components. I unmount the 4 screws on the PSU power supply unit and I drag it out. The PSU or power supply unit's job is to make sure it converts AC alternating current to direct current in the proper quantities needed by the components inside of the computer. Now I've removed the power supply. It's a CX 600 watt power supply made by Corsair. Now I will unplug the data sections of the SATA ports. It's a serial ATA connector which connects to a SATA interface that are located on hard drives and SSDs. You unplug these cables from the motherboard before you can start to unmount the motherboard from the case. Next, I take off the fans. This is so I can get at the components that are located at the top. These fans help with airflow through the case to make sure all the components stay cool and at good temperatures for overclocking from their base clock. When you overclock, it generates lots of heat. This takes the frequency of a processor or memory and it increases it. But this generates more heat and requires more cooling power. These fans that I have in my case are Corsair LED fans. They are used for airflow movement throughout the case, not static pressure, which we would use for radiators. I have 2 fans at the top to bring air in to the case, and I have one in the front and one in the rear to make sure I move it all through the case. Next, I turn the case over to begin unmounting the rear fan. This one pushes the air that's been taken in through the front fan, which I will not be unmounting because it is attached to the case, and the 2 at the top, and it will push all the hot air out. Now I start to unplug all of the connectors that connect the case I/O, and I start unplugging the memory from the motherboard. These are each 4 sticks of DDR3 memory clocked at 2400 megahertz. The memory was running in a dual channel configuration, which allows optimal memory speeds, especially if you only have 2 sticks. Next, I start unmounting the graphics card and the Wi-Fi card. The graphics card contains a GPU, which is used to process things for monitors and large data sets. This is a very old GPU, and I will not be reinstalling this one when I reassemble the build. The Wi-Fi card is critical to make sure that a board without built-in Wi-Fi can receive Wi-Fi. Both of these cards get plugged into a PCIe slot. Next, I start unmounting the motherboard. There are 9 screws on my motherboard, which is a normal ATX motherboard. As I remove the motherboard, I make sure to handle it carefully and set it on the box. Next, I remove the I/O shield. The I/O shield is just to make sure that the interface for the motherboard is carefully put in the right place. Next, I set the motherboard on its box and begin to deassemble the cooler. The cooler makes sure that the CPU stays at optimal temperatures, because under a heavy load, the CPU will start to get very, very hot and can cause crashes in your computer. Now that I've removed the cooler, which is a Noctua NHLI, which is a low profile cooler, I began to get supplies to clean the thermal paste off the CPU and the block that contacts the CPU. Thermal paste is used to fill microscopic bubbles between the CPU heat spreader and the heat spreader on the cooler. Normally, you just take nail polish remover or 99% isopropyl alcohol wipes to remove something like NTH1, which is Noctua's uh, thermal paste. You make sure to scrub it cleanly off to make sure this old thermal paste is removed. You also take it off of the CPU. As you scrub the thermal paste off the CPU, be careful not to drip any alcohol on the rest of the board, as this can cause, as alcohol is often, if there's a spark, can cause a flame, or electricity can go through it and can fry your board. I previously had a Core i3 Skylake processor clocked at 3.2 gigahertz, but now I'm upgrading to a Core i7 7th generation Kaby Lake 7700K. The K means it is an overclockable CPU that is unlocked, and its base clock is at 4.2 gigahertz. Now make sure when you take out the CPU to only grab it by the green silicon sides, and then be sure to drop it in very carefully. Align the triangle with the triangle on the socket and put the CPU. Then push the retention lever and pull the retention arm underneath. There will be a slight cracking noise, but that's normal. Now it's time to reapply NTH1. This is a thermal compound that I used previously, but this will be used to make sure all the microscopic bubbles are filled in to create optimal heat transfer. Now I remount the cooler to the board, and as I turn the board, I will screw in the back screws into the back plate to ensure a secure contact between the CPU cooler and the CPU. Make sure to go side to side diagonally as to not create too much pressure on the PCB, which is a printed circuit board, and cause it to flex and break or warp. Now I install the final screw and make sure the cooler is on securely. And I tighten these in a diagonal pattern. Next, I reinstall a new video card, which is a dual GTX 1060 made by ASUS. This is an upgraded graphics card compared to the GT610 that I had previously made by NVIDIA. I reinstall the memory into the same colored slots to ensure that it's in dual channel configuration to allow for faster memory speeds. Now I remount the power supply in the case. And make sure the fan is towards the bottom where the filter is on the case. This is to make sure that your power supply is not taking in air that is put out by the graphics card, which could be at anywhere from 60 to 80 degrees Fahrenheit, Celsius. Now you screw in the power supply. Ensure you're still grounded using an anti-static strap. This is to make sure that you do not have any static electricity built up and damage components. Now, put the motherboard on top of the standoffs and align the screws with the holes in the standoffs. This is to make sure there's not a short circuit created by the motherboard touching the metal parts of the case. Install the IO shield. Now, begin to get your cables out of the way and drop in slowly your motherboard. Make sure all the screw holes are aligned on the standoffs. Next, make sure everything is tucked in properly and undusted. Now, you start screwing in every single screw, making sure that each screw is put in properly and not over tightened to make sure that the PCB does not work. Make sure your screws are also rubber or plated to ensure that there is no short circuit between the motherboard and the standoffs. Make sure that you put all your screws in a magnetic parts tray to ensure that you do not lose any of your screws during the assembly. I'm screwing in the final of the 9 screws. Now I'm tightening them in a diagonal pattern, ensuring that no too much pressure is put on one point in the motherboard, causing the PCB to flex. As I make sure all of the screws are in properly in the right area, I drop one screw, so I ensure that that screw is put in properly. Now I'm just checking to make sure that the motherboard does not move when moved around, as this, when your PC is moved or jerked, could cause, with a graphics card inside, to make the PCB break, or could cause even worse damage to occur. Now I unmount one of the PCIe bracket slots, but first I must unscrew and rescrew the power supply to get at one screw. I ensure that the motherboard's retightened, the backplate screws are in properly. The black plate just ensures that with the CPU cooler mounted to the motherboard that the PCB does not flex. Ensure all of the screws are tightened properly and that the front I/O shield is aligned with the I/O on your motherboard. Next, make sure you manage your cables well, as this will help with airflow. Plug in your cooler's CPU controlled fan header into the slot. Next, I will be taking my new GPU or graphics card, and I will be installing it into the case. This is a 2-slot card compared to my 1-slot PCI card, so I will be having to remove one more. Be sure that when you remove parts from your anti-static bag, not to put them over it, as the electrical charge goes around the anti-static bag rather than in through it. Therefore, it will damage your components, not help them from keep them static electricity safe. Next, I install the card in properly into the slot, making sure that the lock clicks on the PCIe slot. Then I find the 2 connectors needed to power the graphics card. This needs a 6-pin connector. Next, I install the TP-Link dual band Wi-Fi card into the case again. As I make sure the graphics card is seated properly and screwed in to make sure it does not warp or break the PCIe slot. Make sure all of your cards sit properly inside of the slot without any movement, otherwise there could be a loose connection or even worse, a breakage in your motherboard. Make sure and retighten all of your screws to ensure that the graphics card and your Wi-Fi card are inserted properly. There's no need to insert a Wi-Fi card if your motherboard has built-in Wi-Fi, but mine does not. If you are to buy a Wi-Fi card, make sure to get a Wi-Fi and Bluetooth card, as if your motherboard does not support Wi-Fi, it will likely not support Bluetooth either. And Bluetooth is very important for other features if you want to ever connect any external Bluetooth accessories to your computer. Remember that your computer does not come with microphones or speakers, so get a display that has microphones and speakers or buy an external microphone. Now I am remounting the hard drive. This is a 1 terabyte WD Blue hard drive, which is just meant to store data, not for server applications. This hard drive uses a serial ATA interface. As I route cables in to plug into the graphics card's 6-pin header, I also have to route the 24-pin motherboard connector to the motherboard. Make sure that the locks go in with the side with the hinge on it. Otherwise, it will not click in. And make sure that the lock clicks. Otherwise, if there is a loose connection, your computer will not start up when you boot it for the first time. Ensure that you plug in your hard drive and SSD, give them power and data, and give them a secure connection to the motherboard. Ensure that you have a bootable volume on your computer so you will actually be able to use it. Otherwise, you will need to install a copy of Windows, Linux, or Mac OS when you boot. try to get the best cable management you can with a modular power supply. They do cost a little more, but they are definitely worth it. Another thing to consider with power supplies is to make sure that you do not, if your system only takes 400 watts, to make sure to get a 600-watt power supply, as there is a bell curve to efficiency, and your power supply will be highly inefficient if you get a 400-watt power supply for a 400-watt build. Now I'm plugging in the front I/O to the case. This these connectors are very, very tiny, so it is very hard to see. You plug these in one by one, the LEDs and the USB headers, audio and microphone headers for the computer in. If you are using a motherboard without isolation for sound, the electrical the electrical components can interfere with sound quality, so you might want to buy a sound card. If you are to use high quality sound products, do not plug in your headphones to the front of your case if you're using a low grade motherboard, as the case as the front of the case will just sound very noisy and bad. If you want to if you have high end microphones or speakers, plug them in through the back as not to get a electrical humming noise. Plug in all of your front I/O cables very safely and properly as to ensure that you do not break any pins on the connectors or to damage it so you will not be able to boot your computer externally. Now you will want to start installing the last of your cables as the CPU cable, which is an 8-pin connector, your USB Type B connector, which is also another 8-pin connector, and the rest of your case fans. Make sure the leads of the cables are plugged in accurately and properly, as if they're not plugged in with the right polarity, you can short circuit the front LEDs and create many other problems to your front I/O. This is a very time consuming task, especially when other cables are in your way. Now plug in all of your SATA, SATA, the data section of your SATA ports into your motherboard as to ensure that what drives need to be the fastest are connected to the 6 gigabit per second interface and the slower drives to the 3 gigabit interface. Now reinstall your case fans in the proper directions for push and pull as you would like for your system. My system, it has a front intake and intake from the top and gets exhausted through the back as to ensure that all of the lots of air is quickly circulated through the computer as not to overwork the graphics card or the CPU fan. If you get a modular power supply, ensure that there's good cable management. This will be especially easy for you as the cables won't create any air resistance and your build will look much cleaner. Make sure that your fans are secured properly as so they do not fall down while you're using your computer. Then install their headers into the proper slots on your motherboard so you can control them and give them power from your BIOS. Now I'm mounting my rear fan. This is a blue LED fan, as my front fans that all intake air are red. My exhaust fan is blue to make sure that I know how the airflow flows in my computer. You might want to color code your fans like this. Now make sure that everything's screwed in properly as last minute checks, and mount and put in the SATA interface connectors into your hard drive, SSDs, and optical drives. Ensure good contact so that you do not have to reopen your case to fix this. Use the rubber grommets and mounting and cable holes to route your cables through the back of your case is to ensure a clean look from the front. If you do not want ketchup and mustard cables, you can get custom cables created on online websites. Here I'm just finishing plugging in everything and ensuring that it has secure connections. Make sure all of your connections have secure connections, as this can create many problems when trying to start your computer up for the first time. Make sure always to use anti-static protection as to not damage your components. After you finish installing everything, put on the back panel and screw in the thumb screws. And if you have a tempered glass panel on your case, put in the front panel and screw in the thumb screws. Don't screw them in too tightly, as if it's your first time booting up a computer, it may need some internal work still. Also, if you can get dust filters, please ensure you get dust filters, as this will prevent components from getting dusty and needing cleaning later. Now you know how to build a computer. That's all. Bye bye.